Hello to everyone and welcome to Nonin SpO2 education. The objective of this training is for you to develop a comprehensive understanding of pulse oximetry technology, along with the advantages of choosing Nonin pulse oximetry to provide the best possible care for your patients. For you to develop that understanding, we'll dive into the following topics. I will start by providing an overview of pulse oximetry. I'll review the physiology and science of pulse oximetry. I will describe how we conduct our pulse oximeter accuracy studies. I will then showcase how Nonin has demonstrated accuracy and clinical results that support our accuracy. Lastly, we will lay out the key differences in Nonin technology. So what can you expect to take away from this today? You will learn what the true gold standard is for determining accuracy in pulse oximetry and how leading companies like Nonin compare to that standard in challenging conditions, which is when you need reliable pulse oximetry the most. You'll also learn why pulse oximetry has historically been monitored from the finger, along with key aspects of Nonin technology that have demonstrated accuracy in low perfusion and skin pigmentation. Let's get started. You can see right away where the Nonin name comes from, as it's short for non-invasive. Pulse oximetry is what some people refer to as the fifth vital sign. It is a non-invasive method for measuring a patient's oxygen level, or SpO2, and heart rate. It's a simple, painless way to determine how effectively oxygen is being transferred to different parts of the body and how often the heart is beating. There are, however, some challenges that may impact the accuracy of your pulse oximetry device. Low perfusion, skin pigmentation, patient size, patient motion, such as tremors and shivering, and nail polish can all impact the overall accuracy of a reading. Therefore, it is very important to select a pulse oximetry technology that has demonstrated accuracy under all these circumstances. Now let's get into a bit of the physiology and science of pulse oximetry. Oxygen is vital to the functioning of cells. Thus, oxygen delivery to cells is an important indicator of patients' health. A pulse oximeter uses two frequencies of light, red and infrared, to determine the percentage of hemoglobin in the blood that is saturated with oxygen, and heart rate. This oxygen saturation is an indicator of oxygen transport in the body and indicates if sufficient oxygen is being supplied to the body, especially to the lungs. Oxygen binds to hemoglobin in red blood cells and is transported throughout the body as arterial blood. Oxygen makes the blood red, and that's why arterial blood is red and venous blood is blue. So in simple terms, pulse oximetry reads how red your blood is. Perfusion is the circulation of blood through tissues. The image on the right side indicates normal perfusion of the hand, and areas of greatest perfusion are darker or more red in color. And therefore, we commonly take a pulse ox reading on fingers or toes, as they are usually well perfused areas of the body. So the science of pulse oximetry starts with two different light sources, red and infrared lights. These two different light sources controlled to be on at different times are passed through the blood, as indicated in the image shown. The amount of light that passes through is then picked up by a photodetector, where an algorithm within a signal processor then calculates the SpO2 measurement. The result of this is a number that provides useful information on the patient's medical condition. Impure light sources can shift the calibration and affect accuracy, most notably when the saturation is below 95% and or with dark skin pigmentation. And therefore, high quality LEDs make a difference in your measurements. Nonin's oximetry technology and accuracy all begins with a quality sensor, or sometimes referred to as a probe. And Nonin has 30 plus years of experience in light sensing technologies. Nonin's pure light sensor technology provides only the purest red and infrared LEDs to provide a high intensity pure light spectrum, which eliminates variations in readings for consistent measurements, especially at critical SpO2 levels, such as below 80%. High quality sensors also ensure that accuracy is not degraded due to skin pigmentation. Now let's get into how Nonin conducts accuracy testing studies so you understand how Nonin ensures we are delivering measurements that you can trust. So a pulse oximeter is intended to read the saturation of arterial blood. And referenced is an image of an external OEM pulse oximeter as well as a fingertip pulse oximeter. Now, Nonin conducts accuracy clinical studies to ensure the pulse oximeter's stated accuracy. Now let's discuss the process for accuracy studies. So the true gold standard for saturation is measured on a co-oximeter. And this is a picture of a co-oximeter and a blood gas analyzer. So pulse oximeters are calibrated against an invasive blood gas machine or co-oximeter to determine accuracy to standards and regulatory claims. And a co-oximeter does require a blood draw. And in order to get a blood draw, we place an arterial line in a subject along with connecting the subject to a pulse oximeter. We then take some readings with our device and compare them to the co-oximeter readings. For the average healthy adult, normal saturation can range from between 95 and 100%. However, for patients experiencing compromised respiratory function, their saturation can be much lower. And it is critical that pulse oximeters be able to read accurately in these situations. So we connect a subject to an anesthesia machine and do what we call induced hypoxia. We slowly take away oxygen to lower the subject's oxygen levels, which allows us to evaluate Nonin's accuracy at lower saturations. And we repeat the simultaneous measurement on the pulse oximeter and sensor across a range of saturations. And we then repeat this for a statistically significant group of subjects. So what does that data look like? I have two figures here that will illustrate this study. On the left is a time plot. The lower axis shows time. We plot SpO2 over time. And whenever a blood draw is done, we plot that too. indicated by red dots at the same time. And on the right is a scatter plot, which shows the SpO2, also indicated by red dots, at the co-oximeter reading. And over time, we see the SpO2 reading. And at 46 minutes into the hour, we do a blood draw, indicated by the red dot here. The pulse oximeter read in the upper 90s, and so did the co-oximeter. So we continue this process as we desaturate the subject. And now we see the SpO2 dropping. And the only way to confirm the subject's blood oxygen saturation is indeed dropping is to do another blood draw. So this pattern of pulse oximeter readings and blood draws will continue as we desaturate the subject in accordance with the approved protocols. So then we give the subject some oxygen to build their reserve back up, which you will see here. Now I hope this provides you with a deeper understanding of how Nonin demonstrates accuracy even in challenging conditions. Now let's take a look at how leading companies compare to this standard in challenging conditions. So before we get into too much of the data, I wanted to highlight an important call out within this article. The authors state clinically important bias should be considered when monitoring patients with saturation below 80%, especially those with darkly pigmented skin. So this ensures you can trust your measurements on all patients, even in the most challenging conditions. So all co-oximeters read slightly differently. So the only way to get a true apples to apples comparison on pulse oximetry technology is to compare devices against the same subjects and co-oximeter. And based on a peer-reviewed published study of 3 major oximetry technologies, Masimo, Korth, and Nonin, with varying subject demographics, as you can see listed here, the following illustration represents how each technology compared to the actual blood gas or co-oximeter measurements at different reference values. Now, bias is the mean of the differences between oximeter reading and the functional SpO2 values, as measured by a co-oximeter from an arterial sample. So positive bias means the test oximeter overestimates saturation, and negative bias means the oximeter underestimates the saturation. The Nonin PureSat oximeter with clip sensor was compared with the Masimo Radical with clip sensor and the Korth Oximax N595 with clip sensor. And all 3 of these products meet regulatory accuracy requirements, but they all differ in their bias at different SpO2 levels. And based on the results, the Nonin PureSat oximeter with clip sensor had the lowest bias compared to the gold standard, blood gas or co-oximetry, throughout the oxygen saturation levels and for all skin pigmentations. And in this most challenging environment of low saturation, where the SaO2 is from 70 to 80%, and dark skin pigmentation, the bias for the Nonin PureSat oximetry with clip sensor was minimal at negative 0.6%. This is in contrast to the competitors' clip sensor results, with a mean bias of 2.61% and 2.59% in the same subgroup. And in this study, Nonin readings biased slightly below the blood gas reference, which may ensure greater patient safety, as higher readings may run the risk of failing to identify patient status that could represent a clinical concern. So as we mentioned earlier, bias is the mean difference between oximeter reading and co-oximeter. Precision is the standard deviation of differences from co-oximeter measurements. And accuracy, or ARMS, is a standard method for reporting pulse oximeter accuracy, which combines both bias and precision into a simple term. And as we mentioned previously, all three products meet regulatory accuracy ARMS requirements, but they all differ in their bias, precision, and accuracy at different SpO2 levels. So ARMS error for SaO2 of 70 to 100% is what is used for the Food and Drug Administration device approval. And above 3.0 ARMS is not acceptable. Yet, this study demonstrated that there were several instances of oximeter probe combinations with values over 3.0 ARMS. The Nonin PureSat oximeter with clip sensor was more accurate compared to the gold standard, blood gas or co-oximetry, throughout the oxygen saturation levels and for all skin pigmentations than the competitors with clip sensors. Nonin was the only clip-on fingertip oximeter that provided accurate readings in the tested individuals at all saturations, regardless of skin pigmentation, below or within the FDA acceptable limit. And this study also concluded that the Nonin technology with clip-on probe tested did not show an effect in patients with all the tested skin pigmentations. And this study indicated that the tested Masimo clip-on and Nellcor adhesive sensors read nearly 10 points differently in dark skin subjects at lower saturation levels. So you may ask, why is accuracy so important, or why does it matter what oximetry or oximeter I select? Well, for one, your technology or system helps in the diagnosis or treatment of patients with potentially severe medical conditions. Patients' lives may be at risk, and they deserve the best possible treatment, which is why you need a pulse oximetry technology that has demonstrated accuracy and is FDA cleared. Your system is intended to work on patients of all skin pigmentations, so you need a pulse oximetry technology that is not degraded due to a patient's skin pigmentation. And not all patients are healthy, and the patients most at risk are counting on your system to provide the treatment or care that they need. And oxygen saturation is an important indicator in a patient's health. So don't you want an accurate representation even in the presence of motion and low perfusion? A patient's status may rapidly be changing, which is why you need pulse oximetry technology with a fast response time to ensure treatment is provided on time. And inaccurate or higher readings may run the risk of failing to identify patient status that could represent a clinical concern. And additionally, there are high costs associated with patients being readmitted, which is another reason for selecting accurate pulse oximetry. Now let me ask you, if it were your family member needing care or treatment, wouldn't you want them to be monitored with the most accurate pulse oximetry technology? This is certainly the way that I think about it, and why it is so important to select a pulse oximetry technology that has demonstrated accuracy time and again in challenging conditions and on all skin pigmentations. Accuracy does matter. So from the release of the world's first fingertip oximeter, Nonin has been creating durable and accurate solutions for patients regardless of skin pigmentation. And there are 4 key things I want you to understand about why Nonin is different. Quality sensors, low perfusion filter, true pulse detection, and smart averaging. Now we previously discussed that Nonin's accuracy starts with a quality sensor. All pulse oximeters use red and infrared light to measure SpO2 levels. But Nonin's pure light sensor technology uses only the purest red and infrared LEDs to produce a high-intensity pure light spectrum, which eliminates variations in readings for consistent measurements. Nonin's PureSet technology offers a low perfusion filter that provides a true, reliable reading that is FDA cleared for plus or minus 3% SpO2 accuracy in low perfusion. And this filter automatically removes noise from weak or low perfusion signals to obtain a reading with challenging patients. And Nonin's PureSet technology also features true pulse detection, which reduces false readings by locating the true pulse in low perfusion and motion. And this eliminates false readings due to patient motion, reducing the time required to obtain a reliable measurement. And what we mean by reliable is a measurement that is consistent, trustworthy, and in good quality. It is also FDA cleared for plus or minus 3% SpO2 accuracy in motion. And Nonin's PureSet technology is equipped with pulse-by-pulse smart averaging that automatically adjusts for 3-second averaging or faster. And this saves you time, as there are no modes to set, and the intelligent automatic averaging adjusts for challenging conditions. And the combination of the Nonin PureSat signal processing technology and PureLight sensor technology provides a highly responsive and precise system for accurate and reliable readings, even under the most challenging patient conditions. And these are the key aspects that really help create the Nonin difference. Thank you for your time today. You now have a clearer understanding of the true gold standard for determining accuracy in pulse oximetry and how leading companies like Nonin compare to that standard in challenging conditions, which is when you need reliable pulse oximetry the most. And you also now understand why pulse oximetry has historically been monitored from the finger, along with key aspects of Nonin technology that have demonstrated accuracy in low perfusion, motion, and skin pigmentation. Thank you. Now this concludes the primary content that we shared, that we wanted to share with you. And if you would like to learn a bit more about Nonin's fast averaging and how accuracy of leading companies compare at common intervention points, we will now share some additional content with you. So Nonin Medical's PureSet pulse oximetry technology utilizes an intelligent pulse-by-pulse averaging algorithm that is able to adjust with the patient's condition for precision accuracy. And the pure set averaging algorithm automatically adjusts to provide fast response of 3 seconds or faster with no modes to set or adjust. And in the example shown, Nonin's pure set SpO2 average value was plotted along with the unaveraged SpO2 value taken on each pulse. The pure set SpO2 averaging equals 1 second. And Nonin's intelligent pure set technology provides quick averaging and identifies the true pulse for patient assessment. And this saves you time as there are no modes to set and the intelligent automatic averaging adjusts for challenging conditions. Now, Nonin took the data from the UCSF lab research a step further. Nonin evaluated the study data at saturation points commonly used and defined by medical professionals to help assess the need for intervention. And this first slide looks at 88% saturation point, which is described in various standards and guidelines for intervention. With Nonin technology, more patients were correctly identified for oxygen delivery at the intervention point of 88%. For all patients tested, Nonin identified 91% of patients at the SaO2 intervention point of 88%, where Nalcor and Massimo identified only 25 and 32%. And for dark skin patients tested, Nonin identified 97% of patients at the SaO2 intervention point of 88%, where Nalcor and Massimo identified only 13% and 22%. Now let's look at the 92% saturation point. And this slide looks at 92% saturation point, which is described in other various standards and guidelines for intervention. And for all the patients tested, Nonin identified 82% of patients at the SaO2 intervention point of 92%, where Nalcor and Massimo each identified only 42%. And for dark skin patients tested, Nonin identified 85% of patients at the SaO2 intervention point of 92%, where Nalcor and Massimo identified only 29% and 30%. With Nonin's fast pulse-by-pulse averaging, we can detect saturations quicker. As this data indicates, we are more likely to show desaturations and identify interventions at clinically significant levels. This concludes the backup portion of this presentation. Thank you.